This is our review for the functions and graphing test. We are going to have 3 questions that are on functions and relations, 2 that you're just identifying whether or not it is a function, 1 where you're having to use function notation. Okay, so when you are identifying something that is a function, the x values do not repeat. Okay. So that's all that matters. The way that we test on a graph is the vertical line test. Okay, is a vertical line, like x equals a number, a function. What are my x values? If this was like at -2, what would be all of my x values? -2, right? Would that mean that this is a function? No. So vertical lines, no, not a function. What about horizontal lines, where it's y equals a number? Are any of my x values the same? No. So this is yes, this is a function. Just keep that in mind. So then this one's a set of ordered pairs. We're going to look at just the x values. Do any of my x values repeat? No. So yes, it is a function. Okay. For function notation, we have to substitute in the number that's with the f of x in for x and then solve. Okay. So we have f of 4 equals 2, and then instead of the x, I'm going to put a 4 in. Then I'm going to simplify. So 2 times 4 is 8. 8 minus 3 is 5. And that is how I get 5. Okay. Okay. Composite functions. We're going to do one with numbers and one with variables. This is where you're substituting in multiple times. Okay. So for this first one, we are going to be substituting in 3 into the G problem. Okay. So I'm going to look at my G problem here, and I'm going to substitute 3 into it. So I have G of 3 equals 3 minus 5. And what is 3 minus 5? -2. Now I'm going to replace the G of 3 with a -2. And that is going to go into my F problem. Okay, so -2 is going to go into the F problem now. So I have F of -2 equals 2 times -2 plus 3. Okay, and then 2 times -2 is -4. -4 plus 3 is -1. That is how I get my -1. Okay. If we are substituting in a variable, we are going to rewrite the first problem. So I have G of x equals x minus 5. Well, now x minus 5 is what's going to go into the x problem. Okay. So I'm going to look at my F problem, and instead of an x, I'm going to put an x minus 5. Okay, so I have 2, and then instead of an x, I'm going to put a x minus 5. And we still have our plus 3. So what do I need to do to simplify this? Distribute. So 2 times x is 2x. 2 times -5 is -10 plus 3. I'm still seeing people on equations tests and inequalities tests that are only distributing the number to the first number. It needs to go to both. Okay. -10 plus 3 is -7. And so after we do this, it is 2x minus 7. So however many letters there are, that's how many times you're going to be using them. Okay. So There's 2 letters here, so I'm using 2 problems, okay? I'm using it twice. Yes, Morgan. 3 minus 5 is -2, right here. Okay. So now we're going to have one question on domain and range, okay? When we are working with domain and range, the domain is the horizontal, we're going to look at it horizontally, okay? So that means from left to right. And then our range, we're looking at it vertically. Which means we're going to be looking from the bottom to the top. Okay? They are always written with the small number when we have it terminating. If the graph ends and it doesn't go on forever, they're always written with a small number, a less than or equal to, then our x, less than or equal to, then our large number. Okay? Or with the y for the domain or for the range. Okay? They're always written like this if the graph does not continue on forever. Okay? So when you're doing your test, if you have a graph that doesn't continue on forever, then this is how you're writing it. Okay? I don't want to see anybody writing it any other way. I'm telling you now, write it like this. So when I'm looking at this, what I like to do is I look at my x values. Okay, the first x value that's being represented here is -1. Then I keep going. The last x value here is 5. I like drawing lines, kind of like I'm going to be making like a box. Then I look at my y values. I work from the bottom up. The first y value that's being represented is a 1. The last y value that's being represented is a 7. Okay, I know it's kind of hard to see on your graph. It's small, but on the test it will not have that small of a graph. That's why your papers are a little bit small. That's why, yeah. So just make sure that you always write it like this, okay? Okay. Graphing with X and Y tables. We're going to have 2 questions that are on graphing with X and Y tables. One where you have to identify if it is a solution, and one where you have to actually make the table. So it says, which is a solution to x minus 2y equals 6 when we have the ordered pairs 1, 3, and 2, -2. So what do I have to do with those ordered pairs to figure out if they are solutions? Yes. Yeah, we have to substitute them in for x and y. So I'm going to take my first ordered pair, which is 1, 3, and substitute it in. So instead of an x, I'm going to put a 1. Instead of a 2, or instead of a 3, instead of a y, I'm going to put in a 3. And we're going to simplify. So -2 times 3 is -6. 1 minus 6 is -5. Does -5 equal 6? No. So we need to try our other ordered pair. So I'm going to substitute 2 in for x and -2 in for y and solve. So I have -2 times -2, which is +4. And 2 plus 4 is 6. 6 equals 6. So that is why 2, -2 is my solution. Okay. Then graphing with x and y intercepts, we are going to have two questions on that. One where you have to find the x and y intercepts, and then one where you have to use the x and y intercepts to graph. When you have to use the x and y intercepts to graph, you need to identify the x and y intercepts. Okay. So for this problem, we are going to find our x-intercept first. So what do I have to do to find my x-intercept? What am I substituting in? Or what am I plugging in? 0 for what? Y. Okay, so 0 for y. So instead of a y, I'm going to put a 0. Okay, so that's going to give me 3x equals 6. And then I'm going to divide by 3. So x will equal 2. But I need to write this as an ordered pair. So my ordered pair is going to be 2, 0. Then I need to find my y-intercept. What am I substituting in? 0 for x. So I'm going to get 2y equals 6. Divide by 2. Y equals 3. So my ordered pair is going to be 0, 3. We plot our points on the x and y axis here, and then we draw our line. You need to make sure that you identify these points, though. If you don't identify the points, then you won't get full credit. If you show your work, that's identifying the points. Okay. And then we're going to have 5 questions on slope and rate of change. So just a quick reminder that our two formulas for slope, Rm is rise over run, and that is for graphing. And then R from points is y2 minus y1 over x2 minus x1 is used for points, missing coordinates, and rate of change. So also if our m equals a 0 over a number, then the slope is 0. If our m equals a number over 0, then it is undefined. So we're going to find this slope here. So I'm going to take my second set of information and use that first. So it's going to be 6 and then 4. And then we're going to do, we always subtract. And then I'm going to have a 1 over 4. And that is why I get 5 over 0. And that is why this one is undefined, because it's a number over 0, which cannot be done. Then if we're finding a missing point, we're still going to use our slope formula, and we're going to substitute the information in that we know and then solve for y or x. So I have a y and a 3, so that's going to be y over 3. And then I have a negative 2, 6, so that's going to be 6 and negative 2, and this is always subtraction. And then that's going to equal my m. My m is negative 2. But I'm going to put it over 1 so that I can create a proportion. Then I'm going to do some simplification. So I have y minus 6 still. Then I have 3 minus negative 2. So that's going to be 3 plus 2, which is 5. Now, how am I going to solve this? Using what? Cross multiply. Okay, so I'm going to take 1. I'm going to multiply it by everything. So 1 times y is y. 1 times negative 6 is negative 6. 5 times negative 2 is negative 10. And then I'm going to add 6 to both sides. So y is going to equal negative 4. And then, yes, that's my slope. I just put it over 1 so that we could create a proportion. All right, so for word problems, we're still going to use the y2 minus y1 over x2 minus x1, except for we need to identify our points. So our starting year is 1998, okay? Whatever your starting year, time, whatever is going, we have to identify how many years have passed since the starting. So our starting is 1998. So from 1998 to 1998, how many years have passed? From 1998 to 1998. This isn't a trick question. 0, right? 0 time has passed, right? So your starting year is always going to have 0, our starting time is always going to be 0 for the x, okay? Our y in this case is 1.3, okay? Then we have 2009, so we have to figure out how many years later this is, or how much time has passed, okay? So from 1998 to 2009, how many years have passed? 11. And that, what goes with that is the 2.1. So now I'm going to use my slope formula to find my average rate of change, okay? So I'm going to use 2.1 minus 1.3 over 11 minus 0. And when I take 2.1 and I minus 1.3, I get 0.8. And 11 minus 0 is 11. And then when I solve, I get 0.07, which means it's 0.07, and then it's ppms per year. So whatever the start time is, or start date, that's 0. Then you figure out how many years or how many minutes or hours later it is. And that's going to give you your other x value, okay? Questions? I see some confused faces. Yes. Okay, so whatever the start year is, that's 0, okay? So 1998, because no years have passed yet, it's 0. So let's say that we were doing time, though. Like, let's say that our problem on the notes was, like, something to do with, like, I don't even know, like, the temperature outside. And it was, like, if the temperature outside at 2 p.m., 2 p.m. is your start time, so that's going to be 0. Then at 5 a.m., you have to count how many hours later that is, and that's going to give you your other x value, okay? You can't use necessarily, this case you actually could have used the years, because if you subtract the years, you're still going to get 11. However, if you're using like time, not years, and if we were going from like 2 p.m. to 5 a.m., you can't subtract 5 minus 2 because that's 3. That's not how many hours have passed. So that's why I'm showing you guys 0 and then count how many years later. Does that make sense? Just in case it isn't years, what if it's time? Okay? All right. So whatever the starting year, time, whatever, that's going to be 0. Then however many minutes, hours, or whatever later, that's what's going to go in for the 11, the other x. Okay? So for most of these problems, your first x is always going to be 0. Okay? Okay, now let's look at our next topic, which is slope-intercept form. There's going to be 6 questions on it. 1 where you have to identify the m and b. 1 where you have to identify whether or not they are parallel, 2 graphing, and 1 special case, 1 continuous versus discrete. Okay, so parallel lines. Let's just talk about that for a second. With parallel lines, the slope is the same? Or are the same? Or are the same? That's the erase. So the slopes are the same for parallel lines. All right. When we identify m and b, we need to make sure that it's solved for the equation y equals mx plus b. We have to solve for y. So let's identify our m and b here. So I need to solve for y. So I'm always going to subtract x over first. Okay? Then I'm going to get negative y equals negative 2x plus 8. Then you divide by whatever's in front of y. So in this case, it's a negative 1. So I'm going to divide everything by negative 1. So I get y equals positive 2x minus 8. And that's how I get my m being 2 and my b being negative 8. To identify if something are parallel lines, you have to identify their m's. Well, my first problem here, my m is what? What's the value in front of x? 1. Do I know my m here? No, because I have to solve for it. So I have x plus y equals 2, so I have to subtract x. So I get y equals negative x plus 2. What is my m there? Negative 1. Are they the same? No. So it's no. Special cases. Again, special cases. We only have 2 special cases, and they have not changed. Where we have x equals a number, and that is going to be a vertical line. When we have y equals a number, and there's no x, it's a horizontal line. Continuous versus discrete. So continuous means that you can have values that are in between. Okay? So like fractions. Discrete are values that are independent, like you can't sell tires or people. We're not selling people, but you know what I mean? You can't have a fraction of a person. Okay? So those would be disconnected dots. So continuous is a straight line, and discrete are disconnected dots. Okay? Yes. This part here? Okay, so all I did for this part here was tell me my m, which is what? Is 1, right? Then I took this problem right here and I solved for y. So I subtracted x and got y equals negative x plus 2. Then that m is negative 1. So because they aren't the same, then it's no. No, it's fine. Thank you for asking. Somebody else might have been confused. Any other questions on this slide? Okay. You good? Right. Families of functions. So there are going to be 2 questions on families of functions. One where you have to describe the transformation and one where you have to write a new equation using the transformation. So there's only 2 questions on families of functions. Okay? And I made a poster and it's in the back of the room. So if you need to go look at it during your test, I don't care. You can get up and go look at it. Okay? But let's just talk about this one here that we have. So it's asking us how we transform this. So we added a negative 1 and a negative 3. The negative 1 is inside. So if we look at our transforming functions equation, what letter would that negative 1 represent? H or K? H, right? Which is a horizontal translation. Okay? And it's negative, so that means it's right. Okay? So we moved 1 unit right. Okay? Then we have a negative 3 on the outside. So that is the same thing as K, which is a vertical translation. So that's up is positive, down is negative. Well, this is a negative 3. So that means I'm moving down 3. Okay? So, I mean, maybe writing out the... I'm not going to fill it all in, but you guys can go fill it all in if you want to. But you guys should have done that yesterday when I had it written up on the board. But it's up there too. If you want to go over here by the champs and the functions, the thing that's hanging over there, if you want to go take a picture of it and copy it down later at the end of class, you can do that. Or it was the same thing that was on the board, yes. I just wrote it on a piece of paper so I could erase it off the board. All right. Then we're going to have 2 questions on finding the inverse. Okay, one where you have to find the inverse and one that you have to verify if something is the inverse. So when we are verifying if something is the inverse, you're going to take this problem, the second problem, and substitute it in the x in the first problem. Okay, so my first problem, I have a 2 out front. So I'm still going to have a 2 out front. So we see the 2. Yes. What about the x? I'm going to replace now x. Whenever we replace an x, we always put it in parentheses. I'm going to replace it with this entire other equation. So it's going to be x plus 3 all over 2. There is still a minus 3 at the end of my problem, so I have to subtract 3. Well, my 2's here cancel out because I'm multiplying and dividing by 2. So then I have x plus 3 minus 3. Okay? Well, 3 minus 3 is 0. So I'm left with an x. If you get x, then you're going to try it the other way around. We're going to take my original problem and substitute it in for x into the inverse problem, or the other problem. Okay? If you do not get x, then they are not inverses. You do not need to go on. So my other problem, I have an x. So instead of an x, I'm going to put 2x minus 3. Then I still have a plus 3, and it's all over 2. Okay? Negative 3 plus 3 is what? 0. Then I have 2x over 2. Well, then my 2's cancel out, and I'm left with an x. Because I got x for both, it is yes. Finding the inverses is like what we did before we get started, where you replace x or f of x with y, then switch x and y, then solve for the new y. Okay? Okay. There are going to be 25 questions, okay, on the test. There are going to be 5 challenge questions on the test. We do have a practice test that you need to do, but you also need to study your notes